Here we're asked to solve the equation z squared equals 9 over 4 plus 3i. Given that this is a complex equation, we're going to start by letting z be some complex number, a plus bi, where a and b are both real numbers. So some random complex number that we don't know yet. When we substitute that into the equation, we get a plus bi squared is equal to 9 over 4 plus 3i. Expanding gives us a squared plus 2abi plus b squared I squared. Remembering that I squared is -1 means that we have a squared minus b squared plus 2abi is equal to 9 over 4 plus 3i. And I rewrote the order here very intentionally because now I'm going to equate real and imaginary parts. The real parts are a squared minus b squared is equal to 9 over 4. And the imaginary parts is 2ab is equal to 3. To solve this, I'm going to write this as b equals 3 over 2a. And I'm going to substitute into this equation here. So a squared minus b is now going to be 3 over 2a, all of that squared, which is a squared minus 9 over 4a squared equals 9 over 4. Multiply through and I get 4a to the 4 minus 9 equals, the 4's are going to cancel, so I'm just going to get left with 9a squared, which I'm going to rearrange into the form 9a squared there. Now this is what we call a hidden or disguised quadratic, and we see how to solve this, a lot more examples of things like this in the second unit. We'll come back to that, but for now I'm going to treat this as a quadratic, but it's not in a, it's in a squared. And I can factorize this, and actually I can factorize this to 4a squared and then a squared, and then it's going to be 3 and 3. One of them needs to be positive and one of them needs to be negative to get the minus 9. It's going to be minus there and positive there. And what this gives me, if I expand this, I get the 4a to the 4. I get minus 12a squared plus 3a squared, gives me the 9a squareds, and then the minus 9. So hopefully you can see that that does indeed expand to that. Maybe you could have done that yourself, maybe not, but we will come back to that in Unit 2 to look at those in more detail. That means either a squared is equal to minus 3/4 or a squared is equal to 3. But we know from up here that a has to be a real number, which means that a is equal to plus or minus √3. Now that we have that, we can substitute that back into here, and we get b is equal to 3 over 2 lots of plus or minus √3, or plus or minus multiplying by √3 over 3, rationalizing the denominator here, we can get 3 √3 over 6, or plus or minus √3 over 2. That means our solutions to the original equation are z equals a plus bi, where a is either √3 and b is √3 over 2 times I, or z is equal to negative √3, and then the negative version of this, negative √3 over 2i. So our two solutions to this particular equation are these.